I want to talk about simple radical form, which is a way to write radicals as an exact value, but in a kind of standardized form. There are two rules. One rule is no square factors in the radicand. That means under the square root sign. So you can't have something, it's not in simple radical form if you have a 16 in there, or if you have a square root of 12, because 12 is 3 times 4 and 4 is a square factor. So you can't have any square factors in the radicand. And the other rule is you can't have any radicals in the denominator. So these are just standard ways of writing radicals. So everybody does it the same, everybody's answer looks the same. So for example, no radicals in the denominator would mean something like you don't want to leave your answer like 1 divided by the square root of 2. That would be a radical in the denominator. It wouldn't be in simple radical form. Okay, so I'm going to take those things one at a time and talk about them. But first, I want to talk about and review of some basic rules about radicals. Here are some rules. If you have a radical a, this is all square roots, times the square root of b, that can be written as the square root of a times b inside. In other words, you can take the square root of a first, and then the square root of b second, and multiply those guys together, or you can multiply them together first and then take the square root. For example, you can have the square root of 6 times the square root of 8. If that's written like that, you can then do the square root of 48. Now the square root of 48 is not in simple radical form, but we'll talk about that in a minute. You can also do things like this same rule allows you to go the other direction. So if I have the square root of 48, I can also go the other direction. Let's say I don't want to see 6 times 8, I want to see 16 times 3. So that means I can write it as the square root of 16 times 3 in here like this. And then I can write that as the square root of 16 times the square root of 3, and do those in separate steps and get 4 square root of 3. So this one is in simple radical form now. I just rewrote the square root of 48 in simple radical form. Another rule of radicals is very similar. The square root of a divided by the square root of b is equal to the square root, one big square root of the fraction a over b. Okay, well that allows you to do things like, I'll give you an example of that. If I have the square root of 10 divided by the square root of 5, that could be written as the square root of 10 divided by 5, which is equal to, I can reduce that fraction and get the square root of 2. Okay, well, these little steps can be very handy. And one more thing about radicals is when you add and subtract them, like 3 square root 2 plus 5 square root 2, well, I've got 3 of something and 5 of something, so I end up with 8 of that something, which happened to be the square root of 2. So you can add like terms, but you can't add things like 3 root 2 plus 5 root 3, because those are different sorts of things. So that doesn't work. you can't simplify that one. That is done. These are different problems, but this one's done. That one came from 3 plus by root 2. Okay, moving on. Let's do some examples of what it means to be no square factors in the radicand. Well, that involves factoring. So, for example, we have the square root of 72. Well, does 72 have any square factors in it? Some of this comes down to remembering ways to factor. So that can be written as, think of the biggest factor. Let's say, there's a couple ways I could do this. First thing that comes to mind about 72 is that it's 9 times 8. I just remember that. So I can write that as the square root of 9 times 8. That is going to be 3 times the square root of 8. Then I ask myself, am I done here? Well, does 8 have any square factors in it? Yes, 8 is 4 times 2. So that is 3 times the square root of 4 times 2 under there, and I can take the square root of 4, which is 2, times the 3 that's already out there, and I have a 2 that's inside, so I'm all done. When I get down here and I ask that question again and I say, are there any square factors in the radicand? And the answer is no, so I'm done. But I could have also done that a different way. I could have said, oh, I know the biggest square factor of 72 is 36. Now, if you think of that, you can go straight there and say the square root of 36 times 2. I've got the square root in there, and I can take the square root of 36 right away and get 6 radical 2. Okay, great. I came up with the same answer. I used a little different way of getting there. This first one was a little bit longer, but I got there just the same. If you can think of the biggest square factor, do it, but if you can't, break it down by factoring. Okay, let me do one more example of this sort of thing. Radical form. How about if I have 5 square root, let's try a bigger number, 5 times the square root of 312. Now, some things that you might remember are some factoring rules. 312, is that divisible by 2? Yes. Is it divisible by 4? It is divisible by 4 because the last 2 digits are divisible by 4. That's a divisibility rule for 4. So I could start there. I know it's divisible by 4. I've got a 5 here. Make sure you write all these numbers down because you can lose track of things if you don't. 312, 4 goes into that. 78 times, I think that's right. I'm just kind of guessing here, but I'm thinking that's... Now what about 78? 78 is divisible by 2, and that is 39. So that is 4 times 2 times 39. 39 is 3 times 13. That's... okay, well the only square factor in there is 4. So I get 5, and the 4 comes out as a square root of 4 is 2, and then I've got what's left inside. I'm just going to multiply all that back together. That's 39, that's 7, that was the 78. That really didn't go anywhere. And then 5 times 2 is 10. So this is 10 radical 78. Okay. Next thing we need to deal with is no radicals in the denominator. Well, let's start with the one I had before. 1 over the square root of 2, that has a radical in the denominator. This is sometimes called rationalizing the denominator, because we're going to try and get a rational number, like an integer, in the denominator. So I can multiply this number by, the only thing I can multiply by is by the number 1, but I can write it in any form I want, and I'm going to choose to write the number 1 as the square root of 2 over the square root of 2. I multiply across and I get 1 times the square root of 2, which is the square root of 2, and down the bottom I get the square root of 2 times the square root of 2, and that means 2. Okay, I'm done. There's no radical in the denominator, and the top is in, there's no square factors in the top. What about something like, here's another example, how about 5 square root 12 over square root of 8. Well, one thing I can do is like I mentioned before, is I can simplify this. 4 goes into 8 twice, so that's now the square root of 2 down there. And 4 goes into 12 3 times, so that's the square root of 3. Okay, so really I've got 5, rewrite this again, that's 5 root 3 divided by root 2. Now I'm going to multiply by root 2 over root 2, which is equal to 5 square root 6 divided by 2. There's nothing else. 6, there's no square factors in 6, there's no radicals in the denominator, and everything else is simplified. Do make sure you look at these numbers here if there's any simplifying you can do between those when you're all done, because that's sometimes something that people don't look for. But you make sure all your fractions are reduced, no square factors in the radicand, no radicals in the denominator, and you're good to go. That's it. That's it, except for one thing. I forgot to mention this big no-no that square roots do not distribute over addition or subtraction. What does that mean? Suppose you see something like this that says 5 squared. Now let me try a different number. How about 3 squared? Wait a second. 3 squared plus 4 squared. Well, if we do that, we get 9 plus 16. Square root of that is equal to 25. And some of you might recognize that as a Pythagorean triple, 3, 4, 5. Yeah, I get 5. That's definitely equal to 5. Here's what a lot of times, this is definitely not equal to, this is what I mean by distributing over. You can't take the square root separately if it's addition or subtraction under the square root sign. This is not equal to 3 plus 4 equals 7. And even though that might seem really obvious to you, people make this mistake, and you might even make this mistake sometime. Watch for it. Don't do it.